Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called SVS number 454, which is Little Thermometers by Richard. And here are the rules. Apply classic Sudoku rules, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Clues outside the grid indicate the presence of a thermometer that is fully placed in the direction of the arrow, where all the digits on the arrow add to the number of the clue, and the bulb is always the closest to the clue. I'm going to read this whole thing and then explain it overall. Digits on a thermometer are all different and strictly increasing from the bulb to the tip. Thermometers are minimal 3 cells long, and they include all possible digits. That is, the first digit behind the thermometer may not be larger than the last digit on the thermometer, and the last digit before thermometer may not be smaller than the digit in the bulb. And thermometers may overlap other thermometers. So on every clue that we're given, we have a thermometer that's fully on that diagonal. So, for example, for this clue, there is a 3-cell thermometer, and it has to be going this way. Here, the thermometer could start here, it could start here, or here. Any of those 3, and it has to be at least 3 in length. So it could be 3 there, it could be 3 or 4 in length here for the thermometer going that way. Or it starts here, and it could be 3, 4, or 5 in length for that thermometer. For each thermometer, say we had this set here. What you could not do is you could not say this was like, 1, 3, 6, 7, 8. This is not valid because the thermometer would have to be all of the digits that satisfy the thermometer rule set. So in this instance, 1 would be smaller than the 3, so it would have to be included on the thermometer. And therefore, this sum wouldn't actually be 16. It would be 1 plus 3 plus 6 plus 7 plus 8, because 8 is larger than the 7 that's behind it. And so that's what it means by the first digit behind the thermometer, which would be the 8, may not be larger than the last digit on the thermometer, right? So it would be larger than the 7 in that case. It basically, if you satisfy the thermometer rule set on this diagonal, it must be a thermometer. And what does it mean by the bulb has to be closer? So you cannot have the bulb being not here and being on this side. This is not allowed. It's always the bulb is going to be on the side that's closer to the clue. It's just we don't know where the bulb can be. So this could work if, say, this was like a 4 and this was a 2. Then this would satisfy the thermometer because 4 is going to be greater than 3, so it cannot be part of the thermometer. And this 3, 6, 7, the 2 is less than the 7, so that can't be a continuation of the thermometer here. So the thermometer has to be then these 3 digits, and 3, 6, and 7 add up to 16. So that's a way that the thermometers work. Again, any digits that are before the first digit in the bulb, or actually specifically the first digit, the last digit before the thermometer may not be smaller and the first digit may not be larger than the last digit. So that makes actually a lot of sense. I previously did this. I made another video and then I scrapped it because I didn't understand what the rules are. So I hope that made sense about this clarification of the rules. Basically, the first digit that's right before the thermometer, or the last digit that's right before the bulb of the thermometer has to be larger than the first digit, the digit in the bulb. And the first digit that's after the thermometer has to be less than the the digit that's on the tip of the thermometer. Of course, obviously, you could have the thermometer that's fully on the diagonal, but if you have a smaller one, the last digit before the thermometer bulb has to be larger than the digit that's in the bulb, and the first digit that's after the thermometer has to be less than the digit that's in the tip of the thermometer. And again, all digits on the thermometer sum up to the number that's given in the clue. And thermometers may overlap other thermometers, so keep that in mind. Anyways, I hope this was clear, because it was not clear to me when I first tried doing this previous video, and now I understand the rule set. So I decided to just scrap the previous video and just make sure that this was clear about the explanation. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so we always have 3 cells on the thermometer, so anything that can only be 3 cells must be the full thermometer. So this is 3, this is 3, oops, this is 3. For this angle, it's either 5 or 6, because to add up to 34 with unique digits, you have to have at least 5 of them, right? 4, 6, 7, 8, and 9 is the minimum you can have. So we have to have at least we have to have 5 digits, but we don't know where it starts and where it ends. So these are all on the thermometer. For 7, you have to have 3. For 25, you have to have 4 on this. Because if you don't have 4 on it, it's going to be... You can't have 3 digits adding up to 25. 3 unique digits adding up to 25. So this is guaranteed to be 4. This is 13. We have 3 digits here, so these are both part of the thermometer. We just don't know which. So it's either 1, 2, and 4. So this is 1 or 2. We have 1 being here, 2 with 4 there. Or this is 1, 2, and 4. So we're guaranteed 2 has to be here on this diagonal. To add up to 21, you could have 4, 8, 9, 5, 7, 9, or 6, 7, 8. 17 could be varied. So this digit is greater than 3 other digits. So that means it's at least 4 here. But this can't actually be 4, right? If you have 1, 2, 3, 4, if you have 4 here, that makes this 3, 2, and 1, which does not add up to 25. So this cannot actually be 4. It has to be at least 5. And if you have at least 5 here, the problem is 5, 6, 7, 8, 9 adds up to 35. But if you have less than 5 digits, that doesn't work because it's 5, 7, 8, 9 at most, which is 29, which is too small. So this cannot be part of the thermometer. Therefore, this is part of the thermometer here, which means it extends to here, and this must be 4, 6, 7, 8, 9. So we have 4, 6, 7, 8, 9 there. Therefore, this must be the start of the thermometer here, which means it goes to here. And then this is 1, 2, and 4. This cannot be 4. So it's either 5, 7, 9 or 6, 7, 8. So either way, this is 7. This is 13 without 1 or 2. If we try to have minimum of 4 here, that's 4, 5, and 6 at minimum, which adds up to 15, which is too large. So this has to be a 3 here. So 3, 4, and 6 add up to 10. And that's it. Or 13, sorry. So this has to be 3, 4, and 6 to add up to 13. This could be part of the thermometer. We don't know. So this is done. 1, 2, 4, 3, 4, 6. This can't be 6. This is then 5, 7, 9 to add up to 21. This is at least 1. And it's less than 3 others. So it's 1. It cannot be 6, because 6, 7, 8, 9 add up to 20, to 30, which is too great. 5, 6, 7, 8 adds up to 26, which is too large. So this is 1 through 4 here. This is greater than that, but if this is 1, this would have to be 7, 8, and 9. That's possible. What else? If this is 2, it has to be 6, 8, 9. 3 could be 5, 8, 9. Oh, this can't be 6 or 7. Oh. Well, okay, that eliminates 1 and 2 as possibilities. So then this has to be 3 or 4. 3 can be with 5, 8, 9. It can't be 6 or 7 because it's 6 in the row and the 7 in the column. So 3 could be with 5, 8, 9. It cannot be higher than 5. So I think this has to be 5 then, period, here, right? 3, 5... is 8 plus 8 is 16 plus 9 is 25, so that works. 3, 5, 8, 9, so this has to be 5. Can't be 3, 4, because that adds up to 7. 25 minus 7 is 18, and you would have to have 9 and 9 here, but the thermometer must be consistently increasing. So therefore, this can't be 3, 4. It's guaranteed that's a 5. So we have 3, 5, 8, 9 as a possibility, and 4, 5, 7, 9? Yeah, it has to be 4, 5, 7, 9 as the thing. 4 and 5 add up to 9. 25 minus 9 is 16, so that's 7 and 9. So this is guaranteed to be 9 here. This is 4, 3, 5, 7. Sorry, 3, 5, 8 or 4, 5, 7 here. This adds up to 17. This cannot be 9. Okay. Here we could have the digits 1 through 5, possibly. But this can't be 4. So it cannot be all 5 digits. So there has to be 4, 3 or 4 as possibility. So this is, no matter what, this is part of the thermometer. But that doesn't help much. Same with this. This is always part of the thermometer. To add up to 17 without a 9. You cannot have 1 here, because 1, 7, 8 only adds up to 16. This is 8 at most. You could have 2, 7, 8. 3, it can't be 7 here, though. So that eliminates 2 as a possibility for that cell. This could be 6 at least. What's the smallest this could be? To add up to 17 without 5. So this has to be 6 at most. It could be 7, 6. So this is 7, 8 as a pair, right? If this is 6, this would have to be 3 at most. It's 3 and 6 plus 2 is not, it adds up to 11, which is not 17. It's too small. So I think this has to be 6 then. It cannot be 8, 7 here. It cannot be 5. It can't be 4. 3 and 8. Again, you have 2, 3, 8 at maximum. That's 13, which is too small. So this has to be 6 here. So we have 6. This is 7, 8 as a pair. So 6 plus 7 and 4 adds up to 17. 8 plus 6 and 3 add up to 17. So these two add up to 25 minus 14, which is 11. These two add up to 17 minus 6, which is 11. So this is 3, 4 as a pair, 7, 8 as a pair. You could have 3 digits going there, adding up to 20. Whereas for in row 3, it has to be one of these two cells. 7's here, 7, 8 pair is here, which eliminates 7 in column 1 in these boxes. So 7 has to be one of these two. 8 can't be here or here, so 8 has to be one of these 3. Remaining digits in this upper right-hand box is 5. This can't be 5. This can't... 5, 7, 8, 9. This can't be 9 because of 9 in the row. No 7 because 7 in the row. No 9 because of 9 in the column. Where is 9 in box 3? It has to be here. It also eliminates 5 from in the row. So this is 7, 8. This is 5 or 8. This is 5, 7 or 8. This 7 eliminates 7 here. We have a 5, 8 pair in box 3, which eliminates 5 and 8 in the rest of the boxes. Can't be 8, so it's 7. Remaining digits of row 1. We have 1, 2, 3, and 8. This can't be 3 because of a 3, 4 pair in the column. Remaining digits of box 7. We have 1, 2, 3, 4, and 9. This cannot be 3, 4 because of a 3, 4 pair in the column, and it cannot be 9 because of the 9 in the column. So this 1, 2 pair eliminates 1 and 2 in the rest of the column, so this is 8. That eliminates 8 in the rest of the row. No 8 here, no 8 here. This 1, 2 pair also eliminates 1 and 2 in the rest of the box. So this can't be 1, 2. Cannot be 9 because of 9 in the row. Where is the 9? It has to be here. Remaining digits. This can't be 8 in column 1. There have to be 5, 6, and 7. And this cannot be 5 or 7. So this must be 6, which makes this a 5, 7 pair here. Remaining digits of box 1 are 1 through 4. This can't be 2 or 4 because of the 2, 4 in the row. Okay. Remaining digits of column 3 are 1, 2, 3, 4, and 6. Remaining digits of column 2 are 1, 2, 3, 4, 8, 9. This can't be 8. This can't be 9. So one of these two is a 9 here. So how does this add up to 16? This is always on the thermometer. Remaining digits in row 2, we have 1, 3, 5, 8, 9. No 9 here because of 9 in the column. Remaining digits in row 3 are 2, 4, 6, 7, 8, and 5. No 4 because of 4 in the box. So 2, 5, 6, 7, 8. This can't be 6 because of 6 in the column. 4 in column 4 has to be one of these three because you can't have 4 here. You can't have 4 here in column 4 because the 4 is in the boxes. For 16, for it to be 5 in length, it would have to be 1, 2, 3, 4, 6, which is not possible because that can't be 6. What about 4 in length? You could have 8, 4, 3, and 1. That does work. This can't be the first digit, right? This is at most 7. If this is the first digit, that's 7, 4, and 3 at most. 7, 4, 3 adds up to 14, which is too small. So this can't be the first digit. It must be at least the second digit. It can't be the last digit because that would be 1, 2, 3, 4 at most, which is 9. So it has to be at least there. Can it be foregoing this way? Possibly. It could also be foregoing this way. It cannot be the full 5, though. So, this cannot be 3. Well, it could be 3 if this is smaller, right? If this is part of the thermometer. How about remaining digits here? Remaining digits in this box 6 are 1 through 6. This can't be 1 or 4. No 1 or 4 because 1 or 4 in the column. No 2, 6. No 2, 6. And this can't be 3 because of 3 in the column. Along this path, this cannot be 5, 6, or 9, or 2. So it's 1, 3, 4, 7, 8 as possibilities. This cannot be 4, 6, or 9, so we have 1, 2, 3, 5, 7, or 8. Okay. So on this thermometer, if this is the start, it cannot be 3. Okay, we could have 3 digits here. It would have to be less. Okay, so this has to be less than this. This can't be the starting digit, right? Because again, we try to have 3, 4, and 7 at most. That doesn't work. So this must be at least second. So this has to be less than that. It cannot be 5 or 8. It's 1 or 3, which means this is not 1. This must be greater than that. This must be greater than that, so it can't be 1 or 2. So it's 3, 4, or 8. And this digit, for this to be the starting, it has to be 1. And this would be 2 or 3. We also have a 1, 2, 3 triplet in box 2, which eliminates 1, 2, 3 in the rest of the box. So this has to be 9 here. Guaranteed. Obviously it could be 1, 3, 4, and 8. It cannot be 3 digits. 3, 4, and 8 only add up to 15. So it's either 1, 3, 4, 8 that way. It cannot be 3 unless if it starts here. So if it starts here, it's 1. And if it's 1, this is 3, 4, and 7 at most, which only adds up to 15, so that doesn't work. So this can't be the start. This has to be the start. So we have to go this way. And so this is 1, 3. So that eliminates 1 and 3 here, so that's 2. It can't be 1 or 2, it's 3, which makes this 1. This is then 4 and 8. That eliminates 8 here. This can't be 1, 3, or 4. It's 2, which eliminates 2 in the rest of the column. This 3 eliminates 3 here, so this is 4. Therefore, that makes this 3 and 8 to add up to 17. 3, 6, and 8 add up to 17. Therefore, this is 7 and 4 to add up to 22 with the 5 and the 9. No 1 or 4 here. This cannot be 3 or 4 here. It's 1 and 9 as a possibility. Okay. So this is done, this is done, this is done, this is done, this is done. We need to figure out this 15. This can't be 7 because of 7 in the column. Can this be the third cell? Maybe. It cannot be 4 as a third cell. Can this be the first cell? You have at most 5 and 6. Yeah, 4, 5, and 6 does work here. 7 remaining in column 8 has to be one of these two because it can't be here because of 7's in the boxes, can't be here because of 7's in the row. This can't be 7 here because of 7 in the row. No, 8 here because of 8 in the row. Where's 6 in row 9? Can't be here because of 6 in the box. Can't be here because of 6 in the column, so 6 has to be one of these two. This could be 4, 5, and 6, so this could be the start. Can it be the end? Yes, if it's 8. Maybe. It would have to be 2, 5, 8, which does work. You cannot have 5 digits because this would have to be 4. What about 4 digits? Probably very likely. 4 eliminates 4 here. This can't be 4 because of 4 in the row. Where's 8 in row 6? It has to be one of these 3 digits. 9 cannot be here or here, and can't be in these cells because of 9's in the column, so 9 has to be here. Okay. So it cannot be 5 digits adding up to 15 here. Can it be 4? If it's 4, it must end in a 6. That means the other 3 digits must be adding up to 9. So you could have 2, 3, 4, 6. That does work. Or 6, 5, 3, 1. that works also. So this can never be 1. If that's 1, it's a starting point of the thermometer, and this would be 1, 5, and 6, which only adds up to 12. So this cannot be 1. It can't be 3 because of 3 in the row. Okay. So it could be 2, 5, 8, adding up to 15. Or 4, 5, 6. Or 2, 3, 4, 6 is possibility. It cannot be any digit 4, 5, 6 because that would be too large to add up to 15. So again, the possibilities are 2, 5, 8 to add up to 15. No 1, 6, 8, no 3, 4, 8, nothing that ends in 4 because that's 2, 3, 4 at most. So it's either 2, 5, 8 here. It could be 2, 3, 4, 6 here. Or it's 4, 5, 6, period. But if this is 4, where would 4 be in box 6? Can't be here because of the 4 in the column. Can't be here because if it's 4, 5, 6, that doesn't work. So this has to be 2, 5, 8. It could be 2, 3, 4, 6 as long as that's 4. It cannot be 4, 5, 6. So we're guaranteed this must come from here to there. So how does that work? Can you ever have it not be 2, 3, 4, 6 if it includes this one? Obviously, this is 2, 5, 8 if it's just those 3. It cannot be just these 3, because then this would have to be 4, this would be 6, and that wouldn't be large enough. So I think we always have to include these 2. And it's either 2, 3, 4, 6, or 2, 5, 8. Either way, this is guaranteed to be a 2. So this is 2, which eliminates 2 here, so it's 1 and 2. Obviously, this can't be 1 or 2. It's 3 or 5. And we have 4 and 8 here. Remaining digits of box 8 are 1, 3, 5, 7, 8. This can't be 3 because of 3 in the column. No 5 here because of 5 in the row. No 7 here because of 7 in the row. No 1 or 8 here because of 1 or 8 in the row. No 3 here because of 3 in the row. We are guaranteed 3 has to be one of these 2 digits, which means in column 5, 3 has to be one of these 3. Remaining digits of row 9. 3, 5, 6, 7. No 6 or 7 here. We have this being 3 or 5. This can't be 3 or 7 because 3 or 7 in the column. Oh, we have this. Okay. Cannot be 3 with that. So this is never part of... I mean, this would have to be 1 and 4 to be increasing from this. So this can never be part of the thermometer. How does this work? How would this work? Like, you can't, right? Going this way, this would have to be, so including this would have to be 6, this would be 5, but then that would be, 5, 6, and 9 does work. What about this? 4 would have to be with 7 and 9 for 3 digits. For 4 digits, it's at minimum, it would have to be 4, 5. Okay, well, the problem with 4 digits is this would be a 6. So this cannot be 4 digits away there. So for 3 digits, it's 4, 7, 9, but this can't be 7, so that doesn't work there. So this is not part of the thermometer, which means this is always part of the thermometer. Here, we have at least 3. Since this is always part of the thermometer, it has to be, it can't be 3 digits that way, because this would be 1, that to be smaller than the 4, but this is not smaller than 1. So these two must be part of the thermometer, which means this is 5 and this is 6. So we have 5 here, 6 here. 5 eliminates 5 here, so it's 8, which makes this 5. This can't be 5 or 8, it's 7. This can't be 5 or 7 or 8, it's 6. So there's no 5 here. This digit is necessarily larger than this, so this must be 5, 6, and 9 as the thermometer. So that's done. This is the bulb. That's 5, 6, and 9, which makes this 1. 5 eliminates 5 here, so this is 6. This can't be 5 or 6. It's 1, 2, or 4. This can't be 6 because of 6 in the box. Six eliminates 6 here. It also eliminates 6 here. Where is 6 in box 6? Can't be here, can't be here, can't be here because of 6's in the rows and columns. So 6 has to be there. Remaining digits in column 9 are 1, 2, 4, and 8. No 2, 4 here because of 2, 4 in the row. This is 6 then. Could still be 2, 3, 4, 6. 5 eliminates 5 here. We have a 1, 7, 8 triplet in box 8, which eliminates 1, 7, 8 in the rest of the box, so this can't be 7. This is 3, 5 as a pair. We have 3, 5 as a pair in row 9, so this can't be 3 or 5. It's 7, which eliminates 7 here. Remaining digits of column 8 are 2, 3, 5. This can't be 3 or 5 because of 3, 5 in the row, so this is 2. This can't be 2. That's 3, 5. This can't be 2. It's 1, 4, 8. 8 eliminates 8 here, so this is 4. So this must be 2, 3, 4, and 6 to add up to 15. This 4 eliminates 4 in the rest of the column and box, so this can't be 4. This is 1, 3, 5 as a triplet, which eliminates 1, 3, 5 in the rest of the box. 1 eliminates 1 here, so this is 2. This is 4. 2 eliminates 2 here, so it's 3 and 2. That eliminates 3 from being here. 4 can no longer be here. Where is 4 in column 4? Can't be here because the 4 is in the rows, and this can't be 4 because 4 in the box, so this must be 4 here. Remaining digits in row 6. We have 5, 8, and 9. This cannot be 5 or 9, so it's 8 because of 5 or 9 in the column. That eliminates 8 from being here. This 3 eliminates 3 here, so it's 5, which eliminates 5 here, so it's 9 and 5. 9 eliminates 9 here, so it's 8 and 9. 8 eliminates 8 in the rest of the column, so this is 1, 7, which makes that 8, which makes that 1, which makes that 8. 5 eliminates 5 here, so it's 3 and 5, which eliminates 5 here, so it's 3, which means this can't be 3 here. This can't be 3 in column 5, so that leaves this as a 3. The remaining digit in column 4 is a 6, so that's 6. Remaining digit in column 5 is a 7, which eliminates 7 here, so it's 5 and 7. 5 eliminates 5 here, so it's 1 and 5. This must be 2, and this must be 1. I don't think I would put this as easy. I think I would put this as challenging. It's not, it's a little easier than challenging, but there's some pretty convoluted stuff you have to go through to make sure that this fits. So I would consider this about challenging, a little bit easier than challenging level, but again, I place the grade as harder than what I, if it's between two grades for me. Interesting little rule set here. I could see it being applied to other things, but it seems like there's a lot of potential there for if you want to set rules according to this. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.